Hello, everyone. Just wanted to cover one last topic of today's lesson, and this is the idea of Pythagorean triples. So this concept comes in handy in regards to tests such as the ACT, helps you get a little bit quicker in regards to looking at triangles and different things like that. So I have two examples of two triangles here with lengths. The first one, we have the two legs are 3, 4, and then the hypotenuse is 5. So if we wanted to check this with the Pythagorean theorem, we would take 3 squared plus 4 squared and have that equal 5 squared. And so then 3 squared would be 9, plus 4 squared would be 16, and that's equal to 5 squared, which is 25. And then 9 plus 16 is 25, so 25 equals 25. So this works with the Pythagorean theorem. So this is what we call a Pythagorean triple, because these three side lengths, 3, 4, and 5, work with the Pythagorean theorem. So again, that's what we call a Pythagorean triple. And I have another example here of a triangle with legs 5 and 12 and the hypotenuse is 13. So if we wanted to check this again, we'd use the Pythagorean theorem, a squared plus b squared equals c squared. And so we take 5 squared plus 12 squared, that's equal to 13 squared. And then 5 squared is 25. 12 squared is 144. That needs to equal 13 squared, which is 169. And then 25 plus 144 gives us 169, and those are the same thing. So this works as well. And so this would be another example of a Pythagorean triple. And there are lots of these to explore. These two examples are some of the most specific, some of the simplest ones. That's what I was trying to say. Some of the simplest ones. And so one thing that's also interesting about these is that they can be manipulated and changed. So what I mean by that is, say if we took this first Pythagorean triple of 3, 4, and 5, and then let's say we want to multiply each side these by 2. So get the length of 2, make them 2 times what they are. So that would give us 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. And if we wanted to check this with the Pythagorean theorem, we do 6 squared plus 8 squared, and that's equal to 10 squared. And 6 squared is 36. 8 squared is 64, and then 10 squared is 100. And 36 plus 64 indeed gives us 100. So this relationship works. So 6, 8, and 10, that would also be considered a Pythagorean triple. So if we see a triangle with side lengths that are multiples of 3, 4, 5, that may be a Pythagorean triple. We just got to be careful and make sure that they're each being multiplied by the same thing. So this one's multiplied by 2, multiplied by 2, multiplied by 2. So if we have multiples of 3, 4, and 5, say we have like 9, 8, and 15, yes, these are all multiples of 3, 4, 5, because we'd have 3 times 3, 4 times 2, and 5 times 3. However, it wouldn't be a Pythagorean triple because that one is being multiplied by 2, or the 4 is being multiplied by 2, and the other ones are being multiplied by 3. And then, as another example, if we took this 5, 12, 13, say we had one that's 15, a triangle with legs 15, 36, and then the hypotenuse was 39. This one would be a Pythagorean triple because we'd have 5 times 3, 12 times 3, and then 13 times 3 as well. So they'd all be multiplied by the same thing. Times 3, times 3, and times 3. So this one would indeed be a Pythagorean triple. Alright, so these are just kind of, it helps with speed, as I mentioned. If you see it on an ACT, so if you come up to these first triangles and say you see a triangle with legs of 5 and 12, then you can know by the Pythagorean triple that that side's 13. Or if you come to this first one and you see a triangle with a hypotenuse of 5 and a leg of 3, then you know the other leg would be 4, because again, it's a Pythagorean triple.